My name is Young Kim. I work in the International Aquatic Research Center, University of Alaska, Fairbanks. So my position is the research assistant professor. So I introduce this area. So you can see that this area is the typical black spruce forest. Black spruce is very important to the atmospheric and the carbon dioxide sink reservoir. But in summer season, a lot of lightning in here. So at that time, lots of the wildfire occurred in this area. At that time, a lot of carbon dioxide released to the atmosphere. So CO2 is a very important greenhouse gas. So that is a major greenhouse gas. And water vapor is the most number one greenhouse gas. The other one is the carbon dioxide. So that is one is the natural source, the other one is the artificial source. Artificial source came from, burning of the combustion of the fossil fuel. And then the other one is the natural sources we don't know exactly. So, and then a lot of the scientists concentrate how much it releases to the natural condition such as this forest. So this area is the very important atmospheric carbon dioxide sink reservoir. And then how much the release to the soil organic carbon. The soil organic carbon decomposed rate is very slow. Vegetation is very important because that is how much the accumulated on the ground level. So one is sphagnum moss that has contains the water. So and then the other thing is the feather moss, and then the other thing is the lichen, and the last one is the tussock tundra. My colleague build up the tower system. Tower is and the black spruce, the canopy, and then atmospheric interaction. How much changed the CO2? So and then they captured that. So my portion is to measure the on the ground level, and then just above the atmosphere. So and then how much the release to the soil and the soil component. My automatic chamber system consists of NDVI, that is a non-district and infrared radiation CO2 analysis. That is a commercial CO2 analysis. And then the other one is, you can see it's just a noise. It's a pump. Pump is working the 24 hours, and then a week. Every time is sucked the air from the chamber. So and the other thing is accumulated the data in the data row. That also the commercial and the purchase. So and then my system is 16 chambers, and the pump, CO2 analyze, data logger. I set up that system, so each vegetation has the carbon content is different. So especially soil organic carbon is different. So usually the soil chamber system is open. The ladder is open, and that is and then release to the interaction of the air. But and then target chamber is the chamber is closed. The target and CO2 is released, accumulated in the inside the chamber. That is we have the 5 minutes the chamber inside the chamber CO2 concentration. So and then that is accumulated. That we calculated the gradient. So we change the exactly how much, how area to release to the CO2. So and then we calculated that system. Most people use the dynamic chamber, just the one time setup and collect the data, sample and back to the lab, and then analysis the data. But that is just 1 day is just a snapshot. But this automated chamber system is I show the daily variance of the CO2 flux. So as well as the daily and the monthly, and as well as the annual. So I can calculate how much the release to the CO2 to the atmosphere. My hope is to predict the near future how much the changes in this area. So at that time, how much release to the carbon dioxide from the soil. So we don't know. And then I need the more measurement, long-term measurement of soil respiration data.